first talk this morning is plastic prototyping methods. And we have a panel today, and how do you choose the best process? It's going to be my pleasure to introduce our moderator for that, who will then introduce his fellow panelists or have them introduce themselves. It's my pleasure to introduce Michael Poloyan.
Thank you, Bill. Okay, very good. First of all, before I begin, I'd like to introduce our distinguished panelists who've been kind enough to come here and share their knowledge with all of us. First of all, focus on the options that are available to us for prototyping. So we're going to focus on CNC machining, cast polyurethanes, the additive manufacturing processes, and we've had to sort of narrow that down to a small select group, and prototype injection molding. Your reaction to the purpose of a prototype, the aesthetics, and the lead time and turnaround time. How do these considerations weigh into the decision-making process?
Well, I always ask the customer, what's the purpose of a prototype, and is it truly for functional testing, or is it just going to a trade show? And I get both answers. So prototype can be, and again, speed and delivery is also key. Now, if someone wants an injection molded part, speed is not going to be an option for them because they need tooling. So when they look at other machining or additive manufacturing would probably be the best option to go, some form of additive manufacturing. Now,
Thank you. I'll direct this question toward George. The importance of understanding the process that you're trying to replicate, whether it's injection molding or blow molding. There are a multitude of plastic processes. So I'd like to get your feedback on that as a consideration, as well as tolerances and material properties. Three very important considerations in terms of determining the optimum prototyping method.
Again, as Rick said, it all depends on what is your, what's the purpose of the prototype? Why are you building it? Are you making this prototype for just a fit test, a feasibility test, to make sure that everything that you're trying to put together goes together? If it's going to be an injection molded part and you just need something to fit together, just like a feasibility check, then an additive manufacturing process is your best first step.
Thank you. And the next three questions I'll direct toward Al. And the first one is the level of detail, the quality of the prototypes required, and the parameters to be tested and verified. So how would you apply these considerations to selecting a process?
So, level of detail, that's two ways to look at that. Is it the level of detail for an aesthetic purpose? So you want to make sure the model you show, the prototype you show, reflects the appearance that you want it to show, whether it's a reveal line or a certain curvature or something of that nature, a user interface element, or is it truly functional? This is going to be a functional prototype, and that detail matters for the push button switch in the back. You maybe have a compliant surface and you need to replicate that. So that would tell you what process to use, right? Whether AM is going to get you there. When you talk about detail, CNC comes to mind. Not unusual for us to 3D print a part and then in some cases secondarily machine it because you can get a little tighter tolerance in some key areas that way.
In terms of CNC prototyping, this question will be directed toward Al again. What are the advantages of a CNC prototype, and what special considerations should be taken into account for a CNC prototype? In other words, you're dealing with a cutter, unlike injection molding, which you use a multitude of processes to create virtually any geometric shape, including, of course, EDM. So you have to make some modifications, internal radii, the depth of a narrow feature. These things have to be considered when you're CNC machining. So if you would be kind enough to elaborate on that.
Well, you kind of answered that in the slide there. So the advantages, of course, are detail, and you can CNC machine material that is pretty close to the properties you're going to want in the end. So those are two clear advantages for CNC. Precision and material properties are very similar. Design considerations, obviously, machining a draft. You can machine a draft. Undercuts, you can machine, but give you a false positive for ease of molding, if molding was your end game here. Depth, as you point out here, fine radii that are very deep into a part are problematic. If you have a budget for a cutter.
Do you find yourself having to do two designs, one for
Yes.
injection
Yes.
molding and another one for?
Yes, yes. We often do machining. We have a model shop in-house. We send our young engineers down to talk to the model maker. He shows them out and advises them in his own way how to modify the mold or modify the CAD for him, and then they learn as well.
Thank you. How does the material selection affect the design and the final prototype? These parameters include bonding, cutting, stiffness, etc. And are there limitations for materials in terms of availability, stock size, etc.? I'll direct that toward George.
You are limited for, just say you have a very large part that needs to be CNC machined, you are limited to stock sizes of raw material. Depending on what it is, if it's an ABS or a polycarbonate, there are ways to, you can take two slabs of material and then bond them together and then start your machining there, or you split it, you split the CAD data for each slab size, machine them separately, and then bond it together. It's either done with cyanoacrylate or some kind of a solvent. You can use a solvent bond or just glue.
In terms of cast polyurethanes, which is a common method of prototyping, the question I have is how expensive are the parts compared to an injection molded part, as well as other alternative processes? In other words, you can still replicate parts using the additive manufacturing processes. So how does a cast urethane compare to, let's say, an FDM part or an SLA part? And then, in terms of color, do the parts have to be painted, or can you mold coloring? I'll direct these questions toward George.
How expensive are the parts? Compared to an injection molded part, they are significantly more expensive because it's a much more labor-intensive process.
This next slide is just a little notation I inserted in here. I found this online. There seems to be a trend toward the fusion processes in the next 10 years. It looks like the cost, the processes that are going to diminish in demand are the FDM process and the SLA process. But it looks like the fused deposition processes are going to gain a significant market share. And it makes a lot of sense because the trade-offs that you have with the other two processes. It was an interesting notation. I figured I'd share that with you. And with processes, in regards to material properties, the range of materials that could be replicated or processed, the strength versus the build direction, which is a significant consideration. I'll start off with Al McGovern to discuss some of these considerations and properties.
Okay.
You can take your time on this one.
Well, all right. Where to begin, right? So among the three processes, the FDM one has quite a range of materials. I think everybody would agree with that. You can find filaments of pretty much everything out there. Chocolate included, one of my favorites. And size, let's see, so range, I think FDM has the broadest range. Let's just begin there. Strength versus build direction, I think I would go with SLS if it were me. That's pretty uniform there, pretty isotropic. Tolerances versus build direction, probably SLA would win in that competition for me. I know we really want precision prototypes, so this prototype is you're gonna rely on your eyes to tell you some things. I'm not a big fan of that in design engineering, but there are times where that is important. We often go to a liquid process like that, gives you a little more precision.